When we kick a ball so hard that it flies to a certain distance, we commonly think that there is a single force that acts involved in the physical system. But Newton recognized that it is impossible to have a single force. He observed that when we apply the force, there is always a mutual reaction. And so, forces occur in pairs. His explanation is if you press a stone with your finger, the finger is also pressed upon the stone. Or when you are riding in a car that is braked to a quick stop, you push against your seatbelt and at the same time, the seatbelt pushes against you. This is a general idea about Newton's third law, which we sometimes call law of action and reaction. This law states that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. We can state this law as for every force, there is an equal and opposite force. Mathematically, we can express this law as F sub 1 is equal to negative F sub 2, where F sub 1 is the force exerted on object 1 by object 2, and the negative F sub 2 is a force exerted on object 2 by object 1. Notice that, again, there is a negative sign. This indicates that the force is acting in opposite direction. The common example where this law is evident is a rocket propulsion. Here, the exhaust gas is accelerated from the rocket, and the rocket accelerates in the opposite direction. A common misconception about this is on the launch, the exhaust gas pushes against the launch pad to accelerate the rocket. If this were true, then there would be no space travel because there is nothing to push against space. The correct explanation perhaps is that the gas being forced backward by the rocket exerts a force on the rocket, and the rocket exerts equal but opposite force on the gas. Another common example is when you drop a book on the floor. As the book falls, the Earth's gravity acts on it that causes it to accelerate. What is the equal and opposite force then? It is the force of the book's gravitational pull on the Earth. Technically, the Earth accelerates upward to meet the book. However, because our planet's mass is so huge compared with the book's mass, the Earth's acceleration is so small it cannot be detected. At this point, I think it is important for us to have a review of some particular forces because we keep talking about them in Newton's laws, so at least we have same understanding. First in our list is the gravitational force. We usually mean by the gravity is the force that pulls an object directly toward the center of the Earth or down toward the ground. This force is responsible for free falling objects. But even if the body is at rest, this same gravitational force still acts on the body. Say, a table is acted upon by the force of gravity to keep it on ground, right? Next type of force is weight. A common misconception about weight is it is synonymous with mass. Mass is the amount of matter present in a body, and the weight is the magnitude of force acting on that mass. That's why we can compute weight in Newton because it is force by multiplying mass and the constant acceleration due to gravity, which is 9.8 meter per second square. As a type of force, weight is a magnitude of the net force required to prevent a body from falling freely on the ground. Say you are holding a ball and the gravitational attraction of Earth on the ball is 20 newtons. To keep the ball at rest in your hands need to exert an upward force to balance this. We can say then that the ball weighs 20 newtons. The third type of force is the normal force or perpendicular forces. If you stand on a floor, you are pulled downward. The floor deforms even a very little amount because of the force you are exerting on the floor. But you remain stationary because of the perpendicular force that the floor exerts on you. That perpendicular force is the normal force. Another example of force is friction, which we know as resistant force. When we walk, the surface exerts frictional force on our feet so as not to stumble. This force is always opposite to the direction of the intended motion. And lastly, the tension. When we pull a cable or rope attached to a body, the cord pulls on the body with a tension force away from the body and along the cord. In this type of force, the cord or cable or string or other such objects is typically referred to as massless, meaning its mass is negligible compared to the object's mass, and unstretchable. This cord serves only as a connection between two bodies. These are the common types of force that we are using in the study of motion. Can you name other forces that I might miss? Feel free to add in the comment section of this video. Also, we had completed the discussion of three laws formulated by the great English scientist Isaac Newton. For the third law, remember that the action and reaction of forces are present, where forces are acting on two different bodies in similar magnitude, but from different directions. That is all for this lecture. I am confident that you understood well our discussion. But in case you have questions or clarifications about our topic for this week, feel free to send me a message. I provided some drills in BBL for you to master these concepts in preparation for your graded assessment for this lesson. Once again, I am Gilmar De Castro and see you in the next video.